A transformer is an electrical device that transforms or changes the value of voltage and current. A transformer that changes voltage from lower values to higher values is usually referred to as a step-up transformer. Step-up transformers are commonly used in transmission systems. In a distribution system, however, you're most likely going to find step-down transformers. That is, a transformer that changes voltage from higher values to lower values. In this part of the program, what we want to do is give you a basic understanding of how transformers work and teach you how to recognize the typical types of transformers you'll find in distribution systems. We'll use this simplified illustration to show you how the basic elements are arranged in a typical pole-top transformer. You can recognize this type of transformer by the cylindrical housing, the large primary bushing on the top of the housing, and 3 secondary bushings on the side of the housing. This illustration is similar to the kinds of transformers you see on many overhead distribution systems. The primary winding in this transformer is supplied with primary distribution voltage from a distribution line on the pole. Primary voltage is applied through this lead that runs through the primary bushing to one end of the primary winding. The other end of the winding is tied to the transformer's housing, and an external ground is applied. The secondary, or utilization voltage induced in the secondary winding is tapped off the transformer through leads that pass through the secondary bushings on the side of the housing. In this example, the lead passing through the middle bushing on the secondary side is grounded. The leads on either side are hot. The secondary leads are usually connected to wires that form a secondary bus, which supplies consumers with electricity through service drops. Here's a typical pole-top transformer. Let's identify the elements that allow you to recognize this component as a transformer. First, it has a large primary bushing on top connected to a distribution line. Second, smaller secondary bushings are located on the side of the housing. Finally, the wires coming off the secondary bushings form a secondary bus and service drop going to a customer. This is also a pole-top transformer. It looks and works exactly like the one we just discussed, except instead of one large bushing on the top of the housing, this one has 2. This bushing allows the primary lead to connect to the primary winding, just like we saw earlier. However, instead of having the other end of the primary winding grounded through the transformer housing, this type of pole-top transformer is grounded through this second bushing. Both single bushing and 2 bushing transformers perform the exact same job. They just look a little different. In some cases, the load demand and equipment used by a consumer requires the use of a 3-phase transformer. In an overhead system, 3 single-phase transformers can be connected together to form a 3-phase transformer. Of course, not all transformers are located overhead on utility poles. In areas that have underground distribution systems, pad mounting is a common method of installing transformers. This 3-phase transformer is housed in a rectangular-shaped metal cabinet that sits on a concrete pad. All connections for the transformer are concealed within the cabinet. Single-phased pad-mounted transformers are similar in shape, but their cabinets are usually smaller in size. Inside the cabinet are the primary bushings and the secondary bushings.